Number 23. Some people think a pendulum with a period of 1 second can be driven with mental energy or psychokinetically because its period is the same as an average heartbeat. True or not? What is the length of such a pendulum? All right. We're talking about a pendulum. Number 22, we detailed the difference between the formulas, so check out number 22. The pendulum formula here is going to be that the period of the pendulum t is period of oscillation, I should say, of the pendulum, or period of the swing, however you want to call it. It will be equal to now 2 pi multiplied by the square root of the length of that pendulum's arm divided by g. So basically, you have two unknowns in this problem, right? The period, not unknowns necessarily, but two variables, let me say. The period and the length. That's it. The length of the pendulum's arm determines its period. Or the period of the pendulum, if you know that, we can find the length. It doesn't really determine its length, though, but you can think of it that way, that's fine. So what I need to do is basically solve this thing for L. Okay, so divide out the 2 pi from both sides. That's going to be equal to the square root of L over G. Now you know we need to get rid of the square root here, so square both sides. So it's going to be T over 2 pi squared is equal to now L over G, and just divide out now, or I should say cross multiply the G on over. And that's it. There's your formula for L. Plug it all in. So L is now equal to, that's a strange looking L, L is now equal to 9.8 times now parenthesis the period, which is 1 divided by 2 pi, whole thing squared there. All right. So simply, so 1 divided, so let's do 9.8 times then parenthesis 1 divided by parenthesis 2 pi, close both parentheses and square it, and we get a length here of about 0.248 meters. All right, so that takes care of that. Guys, thanks for tuning in. Hopefully this helps. Please remember to help us out and subscribe. See you next time. Take care.